You should be able to graph a couple of things here. One thing is you should be able to graph is y equals log base e of x. Log base e to the x, rather. And you would graph it like any other exponential function. So what you can do is make a table, x, y. Let's put in some inputs for x. Maybe 0 would be a good one. What would be another good one? 1. How about -1? Maybe 2? You could do -2 as well. Now here's the thing. Unlike last week, you're not going to be able to compute all of these inputs, the outputs for these inputs by hand. I can do 0. What's e to the 0 power? 1. E to the 0 power is equal to 1. So 0, 1 is on the graph. But then just use the calculator to get the others. Okay, you might know e to the 1. If the input's 1, it's e to the 1, and then that does turn out to be 2.718. So if you know that off the top of your head, you don't need the calculator, but maybe you don't. You probably don't if this is the first time you've ever heard of e. But then the others, you're going to need the calculator to help you compute them. So let's do that. The natural exponential function, y equals e to the x, is the second function of the ln button. You can almost see the e to the x there. So second function, ln, gets you e to the, you put in whatever you want for the exponent. If you don't believe that e is equal to 2.7, type in 1 and you get 2.7. E to the 1, or e is 2.718, blah, blah, blah. Okay, and it almost looks like there's a pattern there, but of 8s and 2s and whatnot, and 1s, but no, there's no pattern there. This decimal expansion goes on forever without a pattern. It's an irrational, e is an irrational number. Okay, let's do e squared. Second function, ln to the 2. 7 point, okay, we're graphing it. So am I going to be accurate to 2 places past the decimal? No. So how about 7.4? So approximately 7.4. What about -1? You guys want to try -1? I think it's like 0.3 something. So -1. There you go. So maybe 0.4, I guess, we'll round to. What about -2? .1, we round to. Okay, and then just plot those points. Keep in mind where the asymptote should be. We talked about that last week. I'll talk about it again in a second. Plot those points and draw a smooth curve, and you're good. So I'm going to start with the 0, 1. That's a nice kind of home base to start with. And then over 1 up 2.7. Over 1 up 1, 2.7, maybe about there. Over 2 up 7.4, so 1, 2, 3, 4, 5, 6, 7, somewhere in there. So it goes up quickly, just like we graphed y equals 2 to the x the other day. It goes up a little more steeply than that. And then -1.4, I think that's as far as I'm going to take it to the left. And then do you remember what the asymptote is? It's the x-axis, just like for y equals 2 to the x. It's the same for every exponential function unless you add or subtract something to the exponential function. Oh, so what's the equation of the x-axis? What's the height of the x-axis? 0. So y equals 0 is the equation of, this is the asymptote. It's called the horizontal asymptote. Anyway, just connect the dots and don't go past y equals 0, the horizontal asymptote, and you're good. Nice smooth curve. Shoots up pretty quickly. Keeps going, so put a little arrow on the end. Can you find the domain of an exponential function just by looking at the picture? It's not part of the question, but this is something you're going to need to be able to do for the final. Yeah, think domain, left to right. Does it keep going all the way to the left and all the way to the right, the graph? Yeah, it does, and there's no gaps. So when that happens, the domain is -infinity to infinity. That's the set of all inputs. What about the range? And this works for any exponential function. You can look at its graph and get the domain and range. What's its range? Outputs. Think, how low does it get? How high does it get? How low does it almost get to? But not quite, 0. Then how high does it try to get to? Infinity. What kind of symbolism around 0? It never gets to this height of 0, does it? Parenthesis. So that's a little more for your tuition dollar on this one. I don't think they ask you to do that in the homework, but that is something you should be able to do. By looking at a picture, come up with the domain and range. Really important skill.